Hello. We are going to move on to our second section here in Unit 2. So this is Section 2.2. We're going to analyze conditional statements. I think a lot of what you hear today will feel and sound like science class. We're going to talk about hypothesis and conclusion. If you look at the 4 bullet points at the top, we're going to rewrite items in if-then statements. We're going to look at other statements called a converse, inverse, counterpositives. We're going to talk about a biconditional and then talk about some symbolic notation. So again, these are all of the introductory pieces when talking about logic and logical thinking. All right, at the very beginning here, let's define a conditional statement. So a conditional statement is a logical statement. It is a logical statement. A logical statement that has 2 parts. A logical statement that has 2 parts. A hypothesis and a conclusion. A hypothesis and a conclusion. Okay. So an if-then statement, or actually a conditional statement, is a logical statement that has 2 parts, a hypothesis and conclusion. And so what this if-then statement below is a conditional. So what I want to do is add some notation here. Hypothesis. We often use the letter P to indicate the hypothesis. The conclusion will be the letter Q. Okay? So this next conditional statement, if it is raining, then there are clouds in the sky. So if I wanted to identify hypothesis and conclusion, after the if is going to be the hypothesis. So right here, it is raining. So that's our hypothesis. Okay, or we'll use the letter P. So I'll kind of write both parts right now. Then we'll provide me the conclusion at the end. Then there are clouds in the sky. So there are clouds in the sky represents conclusion. And again, we call that a Q. So notice the word if and the word then don't fall into the hypothesis or conclusion, but it does provide me where they're located. So let me add a couple more things right here. So I'm going to add in symbolic notation, if P, comma, then Q, if we're going to, in order to take our conditional into an if-then. And then in just more notation besides P and Q, it often looks like this. The letter P and then an arrow and then Q. Okay, so I'm going to kind of point to this. That's what this notation means. If P, then Q. So when we see this arrow, that's one thing I want you to kind of say to yourself. When you see this symbolic notation, you would say if P, then Q. Okay, so we'll have directions in words. I'll also have it in terms of notation. All right, so when we rewrite things in terms of a conditional, we will turn it into an if-then. So let's do a couple examples next. Rewrite the conditional statement in if-then form. So all birds have feathers. So I need to determine what is the hypothesis and what is the conclusion, since I don't have the benefit of the words if and then. So I just sort of say this to myself several times, like what's the subject of the sentence? So all birds have feathers. So really, being a bird is the subject. Having the feathers is the result or the conclusion. So being a bird is going to go in the hypothesis. Having feathers is conclusion. So a lot of times I will just write this. I'll put a little P next to birds and a little Q next to feathers. And so then I sometimes have to add words to make the sentence make sense. So a lot of times students like to say, if it is a bird, then it has feathers. Well, you're using the word it too many times. It's not very descriptive. So we have to sometimes throw words in, like I could say, if an animal is a bird, then it has feathers. So I could use it at the end because I've already said kind of an animal at the beginning. So I'm going to go with that sentence. So if an animal is a bird, if an animal is a bird, comma, then it has feathers. Then it has feathers. All right, so that would be my if-then statement. If an animal is a bird, then it has feathers. All right, number 2. Two angles are supplementary if they are a linear pair. Well, I have this nice word if in the middle here, so the hypothesis is always coming after the if. So if I kind of said this in a different format, if they are a linear pair, two angles are supplementary. So I need to reword that a bit. But being a linear pair is going to be the hypothesis. Being supplementary is going to be the conclusion. So I need to talk about the fact that there are two angles that are a linear pair. So I might say something like, I'm going to take the phrase two angles and put it with linear pair. So if two angles are a linear pair, then they are supplementary. Okay, so that would make a little bit more sense in my sentence. So if two angles are a linear pair, or I might say if two angles form a linear pair. If two angles, I will put in the word form. If two angles form a linear pair, comma, then they are supplementary. Then they are supplementary. If two angles form a linear pair, then they are supplementary. So I would encourage you to, I guess, say it to yourself a couple times before you write it down, because if we have too many words like they and it, then it just doesn't give us very many details. Okay, our last one here, 2x plus 7 equals 1 because x equals negative 3. So this one's a little bit tricky because I am interpreting kind of the word because kind of as more of if you're starting with that, then this expression or this equation is equal. Okay, so we're going to say that the hypothesis is the x being equal to negative 3. Your conclusion is that your 2x plus 7 is then equal to 1. So I'm going to continue to use these equations, but add in the words if and then. So if x equals negative 3, comma, then 2x plus 1 2x plus 7 equals 1. Okay? All right, so that would be the process of if we are just given a conditional statement, rewriting it in the if-then format. Okay, let's move on. Let's define negation, and then I want to talk about the bottom here. So when we negate something, think about making it negative, and so number-wise, you're giving it that opposite sign. So that's exactly what we can do with sentences. We can write the exact opposite sentence if we're negating a thought. So, negation would be writing the negative, okay, or opposite. So I'm going to put opposite in parentheses. Writing the negative or opposite of a statement. So to negate a statement is to write the exact opposite. So there is a symbol for this, and it looks like this. So the symbol looks like this little squiggly. So it looks a little bit like we've seen that in the congruent symbol, but this is what we'll use for the word not. So we'll actually use this in terms of symbols. So we've talked about P and Q at the top here. Okay, if P then Q. So we're going to work through those in this next group of sentences down here. Okay, we're going to move on to other logical statements. Okay, so like converse, inverse, contrapositive are words that we are going to define. So to write the converse of a conditional, so think of a conditional would be like an if-then statement. The converse of the conditional, we are switching the hypothesis and conclusion. Okay, so over here to the side, I'm going to say that let's write conditional statement. And so think of this as like your original statement. If P, then Q. So write that notation P arrow Q. So any particular statement, if today is Monday, then I have school. Okay, that would be an if-then statement. The converse is when you switch hypothesis and conclusion. So if I said, if today is Monday, then we have school, the converse would say, if we have school, then today is Monday. Not necessarily true, but it's considered the converse. So the way we show that is instead of writing if P, then Q, we're going to switch the Q and the P. So if Q, then P. All right, so this is my notation for converse. Okay, we're switching around the beginning and end, converse of a statement. Okay, the inverse of the conditional, you're going to negate, okay, which is what we talked about here, both the hypothesis and conclusion. So my example sentence, if today is Monday, then we have school. The inverse would say, if today is not Monday, or if today isn't Monday, then we don't have school. So they say hypothesis, then conclusion, but we want this symbol. So this not P, and then your arrow, and then not Q. And I'm going to add up here the word not, because a lot of times you'll hear me say not, which is negating something. So not P, then not Q is the inverse. And we'll write these sentences out to help this click a little. Okay, the contrapositive is really the combination of the converse and inverse. So one way I've written it out is you're going to first write the converse and then negate both hypothesis and conclusion. Or in other words, we switch them and make them both the negative. So the contrapositive would be not Q, then not P. Okay, and again, these are not necessarily true statements. Some are true and some are false. So we're not going to get a lot into logic. I mean, there is an entire study of logic that, you know, people take the time to study, but we're going to just talk a little bit about it because geometry is really one of the only math courses where you sit and really discuss how to logically process and create mathematical thought. So, okay, I'm going to stop this video because we're going to run out of time. And then go ahead and go to the next video and we will do a couple examples over these 4 statements.